All right, everyone, I'm back. Okay, let's do this again. So I thought about it. I have a new idea. So I think the reason that yesterday we failed on this one, is because we're still going greedy on this, right? We say when we hit a T and the next A, if we can hit the next A, we'll take it. But in fact, we don't really have to do this. Okay, we're trying to go through all possible situations. So what we're gonna do is still BFS, okay, still BFS, but we're gonna have a DP table which records, and we're gonna go from the end to the front again because it's deterministic at the end, and we're gonna record the minimum number of steps. So it's gonna be a DP. We'll have a memo, right? IJ, memo IJ will equal to the minimum number of steps to reach to be at index I for the ring, and attempting to get J on the key, right? And the answer should be the first time that we hit 0. Actually, not the first time we hit 0, 0. It should be the yeah, not necessarily the first time that we hit. Hold on, let me think about it. Maybe it is the first time that we hit, right? Because we're not differentiating. So as we go through the I mean, we definitely can, right? But as we go through the BFS, each time we do it, we'll record the small. So it's like Dijkstra, okay? It's like Dijkstra. So we go through this, and each time if we hit an IJ pair, if the number of steps is bigger than what has already been recorded, then you just don't do it because there's no point doing it. So we can just, Dijkstra it, right? Dijkstra it. So if that is what we're looking for, we don't need this, right? So what we need is an int. We call it DP. Okay, so new int. Now this is interesting because I want to go mn. Okay, we can go mn, and everyone has to be initialized with a very large value. I go with this 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, that's the initial value. Then we have a queue. Well, we probably should just use a deck for this. Okay, I think a deck is a better option for this because I can go front and back. This is right because at the beginning I need to get a queue populated, and then we don't need this honestly, so I can just delete everything here. Okay, so what we want to do is while queue is not empty, right? While queue is not empty, I'll always pop the front. Actually, no, that's not true because I need both. Okay, I need both. So I should say new int I and n-1, right? That's what's hitting at the beginning. And not only that, we have to also do the DP table as well, right? We have to do the DP table as well. So we can say dpi n-1 is equal to 0 because we're not counting the steps that we're pushing the button because we don't have to. Okay, every single letter in the key we have to push the button, so we have at least length of key number of extra steps to do. So all we need to do is to find the steps and then we add that length of the key. Yeah, so we get that, and then we're just gonna get int, we call it tuple, shall equal to q dot remove first. Okay, remove first, and we have I and j, right? We have I and j. Next, what we're gonna do is based on the I and based on the j. Basically what we're saying that because it's like it's a target, right? It's a target, and if they're equal, right? If they're equal, then we'll move on to the next one. Well, we'll count the steps. So we should have a step. You know what? That is true. We should have a step. The level, right? We should have a step, and if they're equal, then we just say, yeah, if they're equal, we will do the step. So we don't do this, and then we do step. Oh, if we do it that way, you need to get 3 of them in, right? You get 3 of them in, and then that's the step. And you say if they're equal, then we will update it. Okay, yeah. I think I'll get 3, so this is gonna be 0. So the step is here, right? So next is we get out, right? We have I, j, and then step. So we check, right? We check. We can say if ring dot get tuple 0, because we got ij, right? If that is equal to key dot get, right? So if the 2 is the same, right? Then we can say that's the first time we reach the target, right, with the current, and then we update the DP tables, and we say DP shall equal to. Actually, this is. So we shall. No, it doesn't. Wait, hold on. Does it matter? Right? Does it really matter? Okay, let me see. So does it matter that because if they did not equal, we're still counting the steps, right? We're still counting the steps. It's only when they're equal that we know, okay, this steps is needed, this step is needed, and all the steps, intermediate step, we still have steps, right? We have intermediate. We still need to count, boom, we hit, go, boom, we hit. So how do we, if they're equal, then we'll move the needle? Is that how? Yeah, if they're equal, then we'll move the needle on the j, right? On the j. If they're not equal, then we continue. Okay, so I don't think. Hold on, I'm gonna pull this out. I shall equal to top 0. J shall equal to 1. Okay, so I have these 3. And then what I need to say is to determine if the step. I mean, we can even do that when we want to push it to the next one, right? We can say if they're the same, right, then we can move it forward, right? We can move forward. Then we can move I forward. Well, I actually need to move backwards. Both move backwards, right? Both move. No, I doesn't matter. J is moving backwards, right? J move backwards, and yeah, I think it doesn't matter. What we shall do is if step is smaller than dpij, right? If that's the case, then we do, or we can say if it's larger or equal to, then we don't have to do anything. I just say continue. Right? The step is larger equal to this. That means we have visit before and we have a better result before. So we continue. Otherwise, then we say depends, right? If they're equal, right? If they're equal, then we can move the needle. Then we can say q dot add last new int, right? We have three situations, right? We have three situations. One is because j is always -1, right? J always -1, so we can say I plus 1 mod m j -1, right? And q dot add last I -1 plus m mod m j -1, or q dot add last. I don't change my position, but j -1. Right, that's the three situations that we can do when this is the case. Otherwise, I can always choose we don't do the current. Oh, what about the steps? Well, that's a move, so step plus 1, step plus 1, step plus 1, and this is the same step because we're not moving, okay? We're not moving forward. So that's if they're equal, right? If they're not equal, I can always say dot add last new int. I can always say, okay, if I don't take it. So if I don't take it, that is the possibility. Like I can choose not to take it. Then it's gonna be I move forward, right? And then I don't move the j. Don't move the j. Yeah, that kind of doesn't make sense to me, right? Why would you not take it? Because you have to take it, right? Because we're doing BFS, so we have to take it, right? Why? What's that? Because you have to take it. There's no point of not taking it. There's no point not to take it. This is not taking it. All right. This is not taking it. This is not taking it. Right, and of course, we're gonna say, actually let's say earlier, dpij. Right, shall you go to step? Then we go on, and now we're done. And then once j is, if step is larger than this, or j is smaller than 0, because j always is this, right? And then we just continue, and at the end, what we're gonna get is return. I think it's TP00, right? Because we need to go back to 0, right? And we do this plus this. Okay, let's take a look, see if this one works. I think it's char. And why you use this? I have ij already out. Oh, yeah, for sure. We cannot do it that way. Damn. Okay, for int row of DP array of fill row. Alright, we'll check it first. J smaller than 0 or this. Yeah, that's a small errors. Okay, right, this one looks promising. Let's try the whole thing. Does this work? Ugh, still doesn't work. Damn. Ah, this one is tough. Let's see any of the easier test case. Okay, let me put this. Does any of the easier test cases work? Oh, is this a forever pending situation? Alright, I might need to refresh the page. But anyway, this one doesn't work. So what this is saying is the minimum number of steps to reach 0, 0, right? Starting from something, and then we just go, because J only decrement. Okay, J only decrement when you have an equal, right? When you equal, then J will decrement. Then we just count the minimum steps to get to 0, 0. All right, I probably need to do this. I probably need to refresh it. Okay, I just test an easy one. Right, does this one work? This one works. How about this one? How about this one? Does this one work? Oh, this one fails. All right, take a look at this one. All right, so we're at A, okay, and then we take, this R and U, or A and let's put this one here. Here's a debugger. All right, so our line shall be here, and then perfect. All right, let's debug this. All right, MS7, this is good. DP, everything is this, that is good. The Q, now I have the first one is 3, 1, 0, because I'm at position 3, 0, 1, 2, 3. I want to reach 1, that's my target, and the step currently is 0. That's correct. Okay, let's go. So tuple I should be 3, 1, 0. Okay. So J is smaller than 0, no. Step it is larger than this, no. So we set DP that equal to 0. Okay, we get it to 0. And ring at this, that is true. Okay, then what we do is, yeah, you know what? I think maybe. Okay, I have this idea of, because they can choose not to count. Doesn't make sense, but I think they can choose not to count. Oh no, that's not right. Still not right. Okay, that's fine. That is fine. Okay, so the next one we put in is so in the queue, Next one, put in 4, 0, 1. Yeah, we try to go 4. And we try to go 0. That's 1. And next one should be 2, 0, 1. Right? We have 4, 0, 1, 2, 0, 1. And we don't move the needle and we move our target. That's going to be 1, 0, 1. Right? So that's our Q. 4, 0, 1, 2, 0, 1. My bad. It's 3. 3, 0, 0. Is that right? 3, 0. Because we're not moving the ring. We're just moving our target. We're not moving the ring. We're just moving the target. We're not moving the ring. We're just moving the target. Yeah, I think that's correct, right? Yeah, that's correct. You're not moving. You're not taking extra steps. All right, anyway, so this is that. And then we go to the next step. Okay, next tuple is going to be 4, 0, 1. Okay, so I'm at 4, position 4 with a U. We try to go 0 and it's not equal. So the minimum to reach is 1 step, right? Then I set it to 1. That is good. Not the same. Then I need to move. So I can go to here. So it'll be 5. Right? That will be 5, 0, 1. Can I keep this open? It's really annoying. 5, 0. 5, 0, 2. Yeah, 5, 0, 2. Or I go that to the left is 3, 0, 2. 3, 0, 2. I guess 3, 0, 2. Now this is what I don't like. Okay, this is what I don't like. Because I have a 3, 0, 0 in it. So this one actually should not be even pushed in. Okay, I'll make change to this later. Anyway, next one is 2, 0, 1 coming out. So I have 2, 0, and 1. Again, we do that. 2, 0, 1, we are at this R, so it doesn't work. So we're gonna do is 3, 0, 2. Now it's 3, 0, 2 coming up again, right? Yeah, we have 2, 6, 3, 0, 2. Yeah, this definitely, we have to fix this. We have to fix this. But anyway, 3, 0, 2 and a 1, 0, 2. Right, 1, 0, 2. Okay, next we have 3, 0, 0 comes in. Okay, 3, 0, 0 comes in. And yeah, so which means that minimal is 0. That's good. And then 3 and 0 doesn't work, so we're gonna go 4 minus 1. Right, 4, 0, 1. Right, we're gonna do a 4, 0, 1 or 2, 0, 1. 4, 0, 1 and 2, 0, 1. Now 5, 0, 2 comes in. 5, 0, 2. 5, 0, 2, 0, 1, 2, 3, 4, 5, 0, 2. Doesn't work. So this is gonna be a 6, 0, 2. Yeah, this is gonna be a 6, 6, 0, 3. Right, 6, 0, 3 or 4, 0, 3. Yeah. Now 3, 0, 2 comes in. Actually, I'm not sure. 3, 0, 1, 2, 3, 0, 2. This is true, right? Because I hit it 4, so I don't do again. Okay, next is 3, 0, 2 again. So we'll continue. Next is 1, 0, 2. 1, 0, 2. I do it. 1, 0, 1, 0. Doesn't work, so we can go. Oh, we hit 0, 0 already. I see. I see the problem. The problem is when we hit it. Sorry. We need to hit -1. because you hit 0, 0 doesn't really work, right? So you have to hit -1. Only -1 will work. Okay, a couple of things we need to change. A couple of things. Yeah, that makes sense, because -1, if j become -1, that is a signal we have completed everything. But because if j is 0, that just means we're trying to target 0, but doesn't mean we have already done 0. All right, so we will do is we need to increment the j by 1. Okay, when increment by 1. This is still fine. This is fine. This is actually fine. Which is when we check DP, we have to check it differently. Okay, we have to check it differently. This is fine. This is fine. Fine, fine. That's all fine. Okay, here is the thing. If step is larger or equal to because I needed to update that as well, right? So I check that first. No, this is right. If it's small, then if it's smaller than 0, we need to continue, right? But no. J is going to be +1. Okay, this is going to be +1 because j is going to be -1, which is fine. Now we just do this +1, and then if steps are larger, then yeah, then we can keep going, and we will not hit a situation where j is smaller than 0. Okay, and then we'll +1. Actually, we will make sure this will not happen because we'll check it before. Yep, we don't even have this. We'll do this, okay, and we say if it's equal to, then we'll compute, okay, int next I. They're all the same, right? So now we can say right is I + 1 mod m, left is I -1 plus m mod m. Okay, so if they're the same, we can move right. Okay, then but we need to check first. How do we check? We say if right step +1, this is the next step, is smaller than dp, move right, and j -1 + 1, right? Because that's the next one. If that's the case, then we will append it. If step +1 is smaller than dp, we'll go left, and j -1 + 1. If that's the case, we move up. Right? If step smaller than dp, we don't move I, and j -1 + 1. Then we do this. Okay, we check it first, then we move. Right? Then we move. Well, we also have to check to see if because j is allowed to be, so we check it here. I would say if j is larger or equal to 0, and this. The next j is for DP, the next j is j minus 1 plus 1. Yeah, we just need to note that. Okay, so this is not necessary. J large equal to 0, and here is the same. J large equal to 0, and okay, else if j large equal to 0, oh, I mean j is always going to be large equal to 0 because I'm not doing anything. So again, the step plus 1 is smaller than dp, because we'll move right, and j plus 1, because I'm not moving j. Okay, j is not minus 1, so we'll have to go this, then we do this. If step plus 1 is smaller than dp left, j plus 1, then we go this. Now when we go to the end, this shall be the answer. Okay, let's try this one. Does this one work? Okay, we have this problem that we did not deal with. -1. We do allow it to go to -1 though. So all these comparisons should be, you know, based on, yeah, so we should do if j is smaller than 0, which we allow, okay? We allow j to be smaller than 0. But how would that be allowed? Because if j is smaller than 0, then we hit it. But if it's j is smaller than 0, there's nothing more to compare. So that's why we do continue. Okay. Okay, we try this one again. This one looks promising. This one looks very promising. Okay, we're gonna do our all the test cases that we have occupied so far. All right, let's run this, baby. Come on. Oh my goodness. My goodness. Big issues, okay? Big issues. We have these. Ugh. Okay, now I have this guess. Maybe we remove this. Give them full choices. Will this one work? Nope. Still don't think that's the reason. Then shouldn't we... Because we allow j to be -1, right? I think one of those things is also wrong. Oh, we have a lot of them wrong. Man. Alright, let's pick one. I think we have 1, 2, 3, 7. The 7th one. Wait, which one is that? I think we got wrong even in hold on. I think we got wrong even in these simple cases. Okay, let's go to simple cases. Like that. I think we got wrong in the simple cases as well. Okay, so the second one is wrong. And the last one is wrong. Okay, let's deal with the last one first. So basically we hit this D. Right, so we have 2. Right, we have 2, 0, 1, 2. So 2, we have 2, 0. Right, we're going 2, 0, 0, and 3, 0, 0. And now we set a step. That's fine. And then we move. Doesn't go. So this is equal. So now we'll check the next one. J is largely equal to 0. That's true. Then we go to the next one, which will be J minus 1. Yeah. Step plus 1. Okay. Okay, I mean, we don't even need to. I don't know why I'm still doing this. I already computed left and right. So this will go right. This is go left. Right, and this is also go right. This will go left. Okay, so we go left, right. JO is minus 1. Yes. And then JO become negative 1. So we'll come back up. We hit. We never get down because we're starting from here, right? So we're going down this, go down this. Because I need to keep moving. I need to keep moving. I need to keep moving. So are you telling me that we should keep doing this? But if we keep doing this, I simply check here. J shall be large or equal to 0, and this. My God. Again, I'll try this to see if this is the cause. So does this one make sense? Nope. Okay, let's try this. Let's debug this and see what happens. Delivery?
For you.
Oh! I did not expect to You have
the ring?
Yeah.
Oh, perfect.
It should be the rings.
Yeah, this says I just ordered yesterday, so I wasn't gonna arrive till 2 today.
Yeah. I'm telling you, this is they give you this under promise and over delivery. That's always make people happy. All right, they always make people happy. All right, I don't even need this. I see I didn't see this. Okay, let's see if I put. Alright, I'm debugging this. DP is this. Q is this. I have 2 because I have 2 G's. Huh? Oh, I have 2 D's. Ooh, the starting is also. The starting position is not right. Because if you go backwards, 1, 2, 3, 4. 0, 1, 2, 3. 0, 1, 2, 3, 4. But that is an issue because you can always the starting you can turn it left or right. Right? You can turn it left or right. So basically this has to be the minimum, right? Because it's your position. So I should say the master minimum I or m minus I. Right, should be the smaller of the 2. But in this case, I don't think it matters. It's still gonna be 2, 3. Right, it's fine. So we have 2, 3. This is at position 1. Yeah. Then we move on. 2, 1, step is 0. And DP that will set to that. Let's go with DP as well. Okay, so that's a 0. And then R, so I can move right. So it's going to be a 3. Move left is going to be a 1. Okay, move left is going to be a 1. And J is logical to 0. That's true. And then we compare the current is good. So step plus 1 is smaller than dpij rj, because r is the next position. J is going to be minus 1 but plus 1, so this is true. So we add the next one. So in the Q we put in 3, 0, 1. Right? We add the 3, try the 0, 1 step. This is also right, so we have 2. Q, if we look at the Q, we have a 1, 0, 1. Right, a 1, 0, 1. And we can also say we want to stay where we are. Right, we want to stay where we are. Then we say 2, 2, 0, 0. Right, we have 2, 0, 0. Right. Move on to the next step. Next is 3, 1, 0. Okay, so we have 3, 1, 0. 3, 1, 0. And then this is all good. 0 and 0 set. 4 and 2. Okay, 4 and 2. So we say. Oh, I think I know. So this shouldn't set here. set it here, right? R and J equal to step plus 1. Then we go it. L and J. Then we do it. I mean, I don't think it matters, but this is the current way of doing it, so I think it does. I do have to do this, so this dp I and j. Alright, because I'm not really moving anywhere. Try to go to step. Okay. Is it the same? Shall I say dp r and j plus 1 to step plus 1. Then we move this dp l and j plus 1. Yeah, I don't think it will make any difference, but it may. Of course, like here we shall say dp I and n equal to 0. Yeah, I don't think it'll make a difference, but it definitely can make it go faster. You just said you don't think it'll make a difference. I think it does make a difference. I don't know. I thought it won't. I thought it's only a performance issue, because I say if it's smaller, then I push to the next. But in the next step, I did update its value. Huh? All this is trying to do is to avoid, repeatedly. Yeah, when you push something into the queue, we want to make sure that its state has been updated in the DP, so we won't push again. But even if we do push again, why would this matter? Right? Why would this matter? Because it's still BFS, right? Why would this matter? Anyway, this a little bit confusing. I don't think it should matter, but it kind of does matter. Does this one work? Oh, I think this one might work. Holy crap. Okay, let's try it again. I mean, still BFS with DP, right? So again, we are doing the same thing. We're saying dp ij plus 1 is the minimum step to reach not reach, minimum step to reach ring I with the target matching, with a target match being key J, right? Starting from right to left on the key. With the attempt to match, key J. Notice that we handle the logic of when to append a new node to the queue not in the body of main body of BFS, but in the conditions. this is to avoid unnecessary addition of nodes, right? Whose previous or has been added
Bueno.
before,
¿Tienes tiempo ahorita o más tarde?
Sí, tengo tiempo.
but not visited.
Bueno, es el mismo número que me mandaste en el mensaje, ¿verdad? Marco ahí mismo.
Sí.
Finally. Wow, this one was tough. 3 hours, because I spent 2 hours last night. Wasn't able to crack it. Went through 2 different methods, and today went through a bunch of more stuff, and finally cracked it. Oh, I'm having a headache now, but overall I think this is pretty good, right? I think it's pretty good. I have 3 situations here, and then we have 2 other situations, and then we use a DP. And this is just a very, very basic BFS, right? Very basic BFS. Pretty basic DP, if you ask me. All right, that'll be it. I'll stop right here. We got a solution, and the next step will be to read the official solution. Man, is it hard? It's, yeah, I don't know. I mean, it took a while to realize that this is a BFS though. That's what take the longest time. All right, anyway, that'll be it. I'll see you guys later today. Adios.